Okay, so today we will learn about unified modeling language. Basically, this unified modeling language is the language for modeling the software development. So today we will discuss all basics of UML principles, what is meant by UML, the history of UML, and basic components of unified modeling language. So what is UML? UML is Unified Modeling Language. Basically, it is utilized for visualizing the software development constructs. So it is a general purpose visual modeling language which can support for all software development cycles. So we know that there are in software engineering course, we have studied that there are so many different kinds of software paradigms are there, prototypes are there, through which we can develop the softwares like waterfall model, rat model, incremental model, agile models. So all these models are specifying how to develop the software and what are the one by one step to develop the software. So there are so many different case tools are supported, right, for development of the software using object oriented methodologies. Okay, so where exactly object-oriented methodologies are utilized to develop the softwares. So all these techniques and their experiences are captured through visualizing, constructing, specifying, and analyzing all the basic concepts in software development through this language. So basically, UML is not a methodology. UML is a visual language, and only it is not methodology. It is a visual language as well as it is a methodology which is accepted by all, that is known as the rational unified process. And this methodology through we are developing the visualizing models. Okay, so basically this UML is started in 1994. So before 1994, each and every researcher or software developers, we can say that, like Scheller Miller, James Ramberg, Grady Pooch, Ivar Jacobson, Cord Jordan, all these authors are specifying their own notations for same object-oriented basic concepts. For example, we can say that Grady Pooch is utilizing the cloud as a symbol for specifying the class. And James Ramberg is using rectangle as a symbol to specify the cloud. So hence, these are the different notations for the same basic object-oriented concepts they are utilizing for software development and we are modeling the software development process, right? And they realize when exactly they have joined that rational company in 1994. So when Grady Booch and James Ramberg has joined Rational Process, and when they work together, they identify that for software development, when they are using cloud for same kind of notation by Booch and same kind of notation from that particular Ramberg, that is rectangle, right? So these are different notations for same basic concepts, and they started working on it. So, and in 1995, then Ivar Jacobson has joined that rational process, and he has developed his own method that is known as OB, right? So, for development, for software development using object-oriented software development, that is known as object-tree. So, and he has using his own process. Grady Bush has using his own process. James Ramberg has using his own process. So that means methodology as well as the notations used for object-oriented software development to model it and to understand it are different by different users and different researchers and developers. So they identify that why not we should create it in unified fashion. So each and every object of we can say that the class can be noted as a only rectangle. So they agreed upon and they have started working in object oriented management group. So basically, this object management group is responsible for creating the unified standard overall through global for software developments. So whatever the number of different standards are generated by these OMG groups, those are free of cost and all industries are agree that particular standards and prototypes they are using. So in 1996, the RFP was accepted by Object Management Group, and then in 1997, this UML proposal accepted by Object Management Group. So initially there is was version only UML 1.x is there, where exactly six diagrams are there. Then later on, as soon as the versions are increasing in the numbers and refinements are taken place in UML diagrams, right? Like initially, then six diagrams, then in 1.6, 1.9, in there is nine diagrams are there, and then UML 2.0 in 2004, 13 diagrams were added. So starting from use case diagram, class diagram, then activity diagram, then sequence diagram, collaboration diagram, communication diagram, object diagram, package diagram, component diagram, deployment diagram, timing diagram. These are the number of different kinds of diagrams one by one added one by one in through versions 1.x to UML 2.0. In detail, we'll discuss later on the diagram details and concepts. So a major upgrade to UML at the end of 2003 takes place, right? And which provides, first of all, the consistency in that particular model elements. They are also kindly specified very precisely defined semantics for each and every object oriented concepts, right? Some new diagrams are evolved there, as already we have discussed, package diagrams and like that. Those diagrams are interaction overview diagrams are evolved. And then all these supports also need to given to backward diagrams also. So this is what exactly the revolution takes place in unified modeling language history. Okay, so in this way, the unified modeling language is evolved. So when we are using a unified modeling language, we should have some process to create software development. So what kind of architecture it is using? So basically, in object-oriented system software development, we are using the model-driven architecture. And this model-driven architecture consists of four parts. First one is the platform-independent model. Second one is the platform-specific model. Third one is the code development. And last phase, that is the deployment of the system at customer side. So initially, we are creating the platform independent model with the help of unified modeling language. So whatever the model is created, it is not considering whether on what platform it will get implemented. Just generalized purpose, all business processes are modeled with the help of unified modeling language. So business process diagrams, use case diagrams, class diagrams, sequence diagrams, component diagrams, deployment diagrams. These all diagrams are prepared without considering any kind of platform. So generalized model has been created in platform independent model. And then if suppose you want to implement in Java based specific model, then all the classes are considered with the help of by considering Java. Then all the integration in between classes or relationship in between classes are considered with the help of JDBC connectivity, right? So these specific models or .NET based specific model is there. Okay, so different kinds of platform specific models from platform independent models were converted. So the conversion from platform independent model to platform specific model is takes place, or transformation of platform independent model to platform specific model is takes place, and then it depends upon what technology you are using. So it is accepted that in SRS itself that the customers wants their model or their implementation must be in Java language, must be supported for .NET. So on the basis of that, the platform independent models are transformed into platform specific models. And once the platform specific model has been generated, through different kinds of tools are available which are generating directly code from that platform specific models, and then the code will get generated. The additional of the code, whatever exactly or functionality, will be getting added by the developer into it, and then the final, we can say that the system will get deployed at customer's environment. So once the whole system is deployed at customer's environment, then the customer environment or the customers or end users will utilize it, and then they will give the feedback. And if anything happens, then maintenance support team and refinement will take place. So this is known as what? Model driven architecture. Okay, so basically this model driven architecture is utilized with the support of unified modeling language. Okay, so this is what exactly your future is there. So we have to first of all generate the generalized model in terms of platform independent model. Then we have to map it into platform specific model, and then generate the code and then deploy it at customer's end. Now we'll discuss why exactly this unified modeling language is called unified. This unified modeling language called unified because of its unification in number of different kinds of several domains. Likewise, there are so many different historical methods are generated for the software development. So across all software historical developments of methods, right, and whatever the notations are used for object-oriented concepts, for all those we required unification, and hence this unified language is created. So why exactly it is called unified? Because from all methods, right, there is rational unified process method is created. Okay, we will discuss in detail in rational unified process what exactly its process. There are four phases of rational unified process: inception, elaboration, construction, and transition. We'll discuss in detail later on. But this method is utilizing that unification is utilized for what kind of software development should be done. So for three, there is one common method has been generated and common notations are being created. And these common notations are called unified methods and unified notations. As well as the all different kinds of software development life cycles are there, processes are there. Those all are different. And hence, when the programmers or the developers are changing the company, they are changing their domains, right? What happens? They are not understanding that particular basic, and they have to learn from scratch again what notation and which notation is utilized for what purpose, which method is utilizing, what life cycle is they are following for object-oriented software development, right? So through all across development of the life cycles, there is one unified life cycle is required, and hence unified concept comes. Okay, so all in application domains, in the implementation language and platforms, in the development processes, and all internal basics of object-oriented concepts, in all across different kinds of methodologies, notations, development life cycles, application domains, implementation languages and platforms, development processes and internal concepts, all these there is unification is required, and that's why exactly this modeling language is called unified modeling language. Okay, now we'll discuss about the basic concepts and the structure of unified modeling language. So basically, unified modeling language models the systems as collections of objects that interact to deliver benefit to outside users. It has the static structure where exactly we can represent that static structure in the form of objects and their relationships. It has also dynamic behavior where exactly the life cycle of objects can be discussed and can be described and can be modeled, right? And how exactly the objects are interacting to achieve the system goals. These can be modeled with the help of dynamic behavior. So every modeling diagrams can be represented. There are so many different kinds of diagrams are there. Those are classified based on the static structure, whether they are representing only the relationship between the objects and their importance, or they are specifying the behavior of the objects. So depend upon that, there are two different kinds of diagrams are there. Okay, so in UML structure, basically, we are having three different kinds of components that is known as building blocks, common mechanisms, and the architecture. Already we have discussed the architecture, like model-driven architecture we are using, right? So all the modeling elements mentioned here are discussed later in much more, like we will discuss one by one now, what is in by building blocks, what is in by common mechanisms, and what is in by the architecture. Okay, now this is what exactly overview of UML structure. Now what is meant by UML building basic blocks? So basically there are three different basic building blocks of UMLs are there. One is things, second one is the relationships, third one is the diagrams. The in things are nothing but the modeling elements. So object is a thing, it is one kind of modeling element. Class is a thing, it is one kind of modeling element, right? So all elements, those are object-oriented concepts, can be considered as the things. And all these things are semantically related with each other. And this relation can be represented with the help of relationships as a basic building blocks. So all modeling elements are tied together Okay, and this bound is known as relationships. Okay, and each and every view of the system can be represented with the help of diagrams, UML diagrams. So we can say that the static view of the system, that is structural view of the system, can be represented by the UML diagrams. Dynamic view of the system can also be represented with the help of view diagrams. Now, from each stakeholder, it will look like that particular modeling concepts from its own perspective. For example, user end user want to interact with your system. So how exactly to start that particular system, to apply different kinds of business processes, to implement different kinds of business processes, how interaction need to be takes place, what one by one steps has to be performed. This is what exactly the views are required by end user. Now, suppose if you are doing it is easy way and your visualization or graphic user interface is very rich and it is understandable by the end user, and what to do next if you are giving specification with the help of dialog boxes one by one. Once the process has been completed, then second process has to be started, so click on this button, like this notifications when we give, and the user gets satisfied and user knows easily, right? So user familiars easily with the help of that GUI, then it is using that software system, otherwise they will not use, right? So it has its own perspective to look from that to look into that particular system's views. So a developer has its own view, how to develop it, how to implement it, how to interact it, how to integrate it. Tester has its own look. So each and everyone has their own views to show that particular modeling, or to accept that particular modeling, or to it should be included into the modeling. So there are different views are showing different interest of their own interest, and these are collections of the things and relationships basically, and these are the views of the different kinds of models we have discussed. So basically in basic building blocks of UML, there are three components are there. One is things, another one is relationships, and third one is the diagrams. So when we discuss about the things are again classified into four different kinds of notation things, and these are structural things. That is the things, those are basic building blocks, we can say that, right? So these are the nouns of a UML model. So when you prepare the SRS, right, software requirement specification or system requirement specification, where exactly you are specifying the general nouns which are specified in the documentation of requirement. And these nouns can be classes, interfaces, collaborations, use cases, active class, components, and nodes. All these are considered as the structural things. Now, behavioral things are there. So, what class is doing, what object is doing, right? So, behavioral things are nothing but need to be identified with the help of verbs of UML model from SRS. So how exactly interactions are takes place? Which is the current state of the object, current state of the machines, current state of the system? These are the behavioral things, right? So for example, currently we are in teaching learning state. Okay, so this teaching learning state is one of the, what we can say that the state of the student as well as the teacher, right? Once the course is getting completed, then you are going for next state, right? So behavioral things are the verbs of UML model. You have to identify it and you have to state it with the help of interaction or state machine diagrams. There are grouping things are also there. So to achieve some common goals, right, you can collect number of different kinds of classes into packages, and one package for is considered for responsible for handling one responsibility. And in such cases, all packages can combine into one system or subsystem, and then this subsystem is providing one kind of, what we can say that the responsibility of the system. For example, in college information system, we required admission process. So admission system is one of the subsystem of college information system, wherein all classes related with admission process will be considered into one package, right? And in such cases, there is admission system is there, then teaching learning process system is there, then examination system is there, right? So all these are collected, we can say that one by one packages or subsystems, and then these are tied together in such kind of relationships that we can have one common achievement of the goal, that is college information system, right? So grouping things are the packages, the models, frameworks, subsystems, etc. There are annotational things are there. So if you want to specify any kind of concept of package, or if you want to specify this class is a boundary class, this class is an interface class, so how to notify it? So either you can use nodes, that is that nodes represented with the help of dog ear rectangle. You can see here this package is given and described with the help of some information about the thing in the dog ear rectangle. So you can have dash line with that particular concept or object or the thing, and you can have dog ear rectangle. In that you can specify the information what exactly you want to specify, separate information. So this is known as nodes. There are different kinds of annotation things are there, like tagged values are also there. So for example, you can say that this class version is 1, this class version is 2, and you want to specify the version. So you can specify that the version is 1.1, 1.0, 1.2, 1.3, 2.0, like this. So in this way, the annotations for those packages or those concepts or those components or the things can be specified with the help of annotation things. We can say that the constraints can also be specified, the stereotype values can also be specified with the annotation things. So basically there are four different things are there, that is structural things, behavioral things, grouping things, and annotational things are there. Now we'll discuss about the relationships. There are so many different kinds of relationships can be considered in object-oriented basic concepts, and we can represent it and we can visualize it with the help of what we can say that the relationships. So what syntax they should have? So for each and every basic concepts of relationship, we are having different kinds of syntax. See the relationships, what we are having in unified modeling language. The first one is the dependence. That means one model is dependent on another model. So when it is a dependency we have to show, we can say that the source element depends upon the target element and may be affected by the changes to it. And it can be represented with the help of dash arrow. Okay, so from source to destination, we can say that that dash arrow has to be represented. So example, we can say that if we are taking banking management system example, wherein if you are changing anything amount from your account, it should get reflected in your account balance. For example, suppose initially you are having 10,000 account balance in you and you have performed withdrawal operation. Now, withdrawal operation is what we can say that withdrawing the amount. For example, you have taken 1,000 from that 10,000. You have done one transaction, that is 1,000 withdrawal operation. So account balance is dependent upon withdrawal transaction. So here the source and target has to be identified. The source is what? Withdrawal balance, withdrawal operation, and the account balance is dependent upon the transaction. So we can say that whatever the transactions you are doing, those need to be reflected in target element, that is account balance. Okay, so in such a way the dependencies are represented with the help of dash arrows when we are representing the models. There is association is one concept. That association is nothing but the links between the objects. So you may have many associations in between two objects, and for each and every association you should have some semantic relationship. So on what basis you are making association? That is what exactly known as semantic relationship. So associations are represented by the solid line in between two objects, right? Aggregation is there. Now, one component can say that it is a main system, and all other components of subsystem, all other components of that particular component can consider as a subcomponent. For example, suppose we are having computer. Now, computer. What are the parts of computers are there? Different component parts. We can say that the hard disk, the motherboard, we can say that the monitor, mouse, and input-output devices, right? Motherboard and the CPU is the part. So we can say that the computer system is comprised of different kinds of parts. So how to represent it? So you can say that computer system is one class, and hard disk is the aggregate part of that particular computing system, right? So we can represent this kind of relationship with the help of aggregation. So whenever there is a kind of relationship is there, then we have to use generalization. Okay, and when there is a part of relationship is there, then we have to use the aggregation. This has to be identified properly. Okay, so whenever there is a part, use aggregation, right? So the target element is a part of the source element. The target element is a part of the source element. Okay, now we can say that there are generalized elements are there. So for example, inheritance is there. In many times in inheritance is utilized with the help of generalization. So you can see that the diamond symbol is utilized for aggregation, which is hollow diamond, which is not filled diamond. But if suppose any part is there, which is we can say that is compulsory part of that particular. For example, computer system will not work without motherboard or CPU. So if CPU is not there, then computing system will not work, right? So we can say that such kind of relationship in between computer system and CPU can be shown with the help of compulsory part, that is composition relationship, and it can be also noted with the help of hollow symbol. Diamond symbol with the help of solid diamond symbol. That means filled diamond symbol, right? So you can see here filled diamond symbol is there. So a strong form of aggregation has been utilized. So there is a containment relationship is also there. That means one package is containing another package. One package may contain 10 different kinds of classes. So you can show that particular package containment, right? With the help of containment relationship, and it has the notation that circle with the help of plus sign. So that is field circle. We can say that hollow circle with the plus sign, and the source element contains the target elements you have to utilize. So it should be at source end. Okay, generalization is the source element is a specialization of the more general target element and may be substituted for it. As we can say that the shape and the area. Now area is generalized from shape class, right? So the shape and the rectangle. So was rectangle is generalized from shape class. So in that case, whenever there is a kind of relationship is there, you have to use the generalization relationship. And whenever you are carrying out some contract specified in one of the model, and you can utilize in another model, at that time you can specify that the realization of that construct is takes place in different system models, right? So this realization can be utilized with the help of dashed, and then triangle is utilized, right? So this is what exactly notation for the realization. So source element guarantees to carry out the contract specified by the target element. So relationships is one kind of what exactly we can say that the basic building blocks of the UML. Now, the third one, basic building blocks, that is the UML diagrams. UML has basically 13 different kinds of diagrams. Basically, when we classify the diagrams, we can say that it can be classified based on the static structure and dynamic behavior, right? So the diagrams can be classified in structural diagrams or the behavioral diagrams. In structural diagrams, there are different kinds of diagrams are there, like class diagram, composite structure diagram, component diagram, deployment diagram, object diagram, and package diagram. Okay, and the behavioral diagrams are specified with the help of the behavioral or the dynamic aspect of the system with the help of activity diagram, use case diagram, state machine diagram, and interaction overview diagram. Now, interaction diagrams, basically, again, it is called as a sequence diagram, communication diagram, interaction overview diagram, and timing diagrams. So all these four are one kind of, we can say that in interaction diagrams are there. So in this way, this is the classification of the 13 types of diagrams as per UML 2.0 concept. Okay, so basically structural diagrams give the specified concept that is known as static model of the system. There are two concepts, as already we have discussed: static model and dynamic model. And behavioral diagrams specify the dynamic behavior of the system. So dynamic models they are specifying. And each type of diagram, basically we can say that class diagram or use case diagram, each and every diagram gives a different type of view of the model. Okay, so you can look at from which stakeholders, that is depend upon you. What is the user's perspective to look at that particular model? Okay, that is its own view of model. Okay, so each and every aspect of the view can be specified with the help of one of the diagram. So you can say that there are 13 different types of diagrams and 13 different kinds of views are there. Okay. Okay. So we have seen this is what exactly the UML diagrams. Now we will discuss about the what is the syntax. Okay, so what is the syntax of UML2 diagram? So basically, UML2 diagram syntax is heading the frame. So you can say that there must be a frame first of all, right? And then you can diagram all components. So this is implied frame. So this is known as frame, and there must be for that frame the heading must be there, and heading should have some syntax, like it should specify what kind of diagram it is. Okay, then what is the name of for that particular diagram you have given? Is there any parameters are required? Okay, so you should have the kinds, you should have parameters, you should, but these are the optional things, but the name must be there, which is a unique thing. So the heading specifies the kind of the diagram, its name, and any information or parameter needed by that element in the diagram. And the frame may be implied by diagram area in the tool, UML tool itself. So you are using any kind of tool, then in that particular tool, you are having that particular implied frame itself. Okay, so whenever you are drawing the diagram on paper, first of all, draw the frame, right? Draw the heading frame. First of all, we can say that where exactly you should give the name, right? That is what exactly the name of for that particular diagram. But if suppose there are some common notations are there, like for example, use case diagram, you can use UD, and then use case diagram's name is there. Use case diagram for employee management system, use case diagram for ATM systems, like that. Okay, so UD can be utilized. Class diagram के लिए CD, for sequence diagram के लिए ESD, this kind of specifications, so that you can understand activity diagram के लिए AD. So this can be shortcuts can be given while you are giving the naming systems. Okay, so this is all about the UML diagrams. Now we will discuss about the UML common mechanisms. Okay, so basically UML has 4 common mechanisms. So what are the different kinds of mechanisms UML is using? Okay, so UML has basically 4 different kinds of common mechanisms that will apply throughout the languages of the UML. So these common mechanisms are specifications, adornments, common divisions, and extensibility mechanisms. So UML has 4 common mechanisms. I'll discuss one by one. Okay, what is meant by the specification? So basically, specification provides the textual syntax or sexual statement for the syntax and semantics of that particular model. So for example, how exactly you can say that now this rectangle symbol has 3 different compartments: the first compartment, second compartment, and third compartment. So how exactly will identify this? Which one is the part of this? So the first part is class name, second part is attribute, and third part is describing the operations or functions. So behind every UML modeling element, there is a specification, right? And that means you can specify it. What type of, what is the name of the that particular class? What are its attributes? What are the functionalities? And its documentation about that particular object model, or we can say that the UML model. So for each and every UML construct or modeling element, we should write some documentation, and this documentation is nothing but the specification. And for each and every of notation, you should have the specification description. We can say that, right? So you should have class description. For use case, you should have use case description or specification. Or for relationships, you should have the dependency relationship. If it is there, then dependency specifications, right? These specifications are created for these are known as the semantic backplane of the model. because if any new user comes, it will see the specification and it will understand that particular model, because through documentation only it is possible. So while you are visualizing any model, you should also document it with the help of its specification. So these are the common mechanisms when we are developing the software development through UML model. There are some add-ons are also there. That means while we are representing any kind of UML component, we should add on it. For example, here this notation, that class rectangle is notation used for class, and there is known as class is window, and this window is created by the author Jim, and it has the status tested. Now this adornment has been given in such a way that they are specified that this window has been created. So it is known as tag values. So some tags are specified. Now you can see that for a size, you are using one plus sign. For visibility, you are using the protected sign, that is known as what, hash sign. So what is the notations of these plus, minus, or hash signs, or the star sign? So these are nothing but the adornments. So they are specifying specific concept. Okay, so every modeling element starts with basic symbol to which it can be added the number of adornments specific to that symbol. So we only show adornments to increase the clarity of the diagram or highlighting the special feature of the model. For example, as we know that in object-oriented system, each and every element may be private, may be public, or may be protected. So for this, you can have plus sign for showing it is publicly available. So size attribute is a public visibility, right? So our public specification. Then protected specifier can be specifying with the help of hash notation instead of visibility. Only visibility is not specifying anything, whether the visibility is public element or whether it is private element or whether it is protected element. How exactly you can specify? With the help of hash symbol. So dash symbol is there, or minus symbol, we can say that, right? So this but the hyphen symbol we can utilize for the purpose of showing whether it is private element or not, right? So in such a way, you can show that the adornments for that basic concepts. Okay. Next is common divisions are there. So you can divide the systems, right? For example, you have to divide the class is separate and interface is separate. So how exactly you are dividing? Which one is the class? Which one is the interface, right? And how exactly they are instantiating. So basically, the classifier and instance has some relationship that is known as instantiate. So with the help of that, you can divide and devise that particular systems. Okay, you can specify some underlying concepts. So instances have the same notations as classes, but the instance name can be specified as an underline. For example, here in bank account, the my account underline is given, right? Okay, and interface can also shown with the help of lollipop symbol. So basically, there are two types of interfaces: required interface and provided interface. So this is what exactly the provided interface symbol. Okay, so the library item is getting provided, right? So it is a borrowable is the interface. So interfaces and classifier instances can be shown with the help of some common division concepts. And at last, there is a common division is known as extensibility mechanisms. So as already we have discussed, whatever the basic component is there, it has its own meaning. It has its own meaning, and we can extend its meaning or its specification by adding some information into it. So we can add either stereotypes, right? And those can be represented with the help of gullimets. You can see that less than and greater than symbols are here, two, right? These are known as gullimets, and this symbol is known as what? Stereotype. So here ticket is the class, but ticket is an entity type of class. Which kind of type of class ticket it is? It is an entity type of class. So hence, this is we are specifying separately with the help of stereotype. So if you want to apply some constraints also, you can use dog ear rectangles, and in curly braces, you can write down the constraints, right? And the tag values are also there. As already we have discussed, every class can be considered as its own version. So we can specify in curly braces the version name also. So version is equal to 1.1. So 1.1 is the tag value. The specification of what kind of class it is, it can be specified with the help of stereotype like entity. It may be the control class, it may be the boundary class, it may be the entity class, right? So entity class is directly reflecting with the database element, right? Control classes are basically business processes, and boundary classes are related with the GUI specifications. Okay, so what kind of class it is? It is entity class. So stereotypes is nothing but what? It is allowing one kind of element to define itself and extend its meaning. Okay, so a stereotype allows us to define new modeling element based on the existing one. We define the new semantic of that stereotype as per our own views. Stereotypes add the new elements to the UML meta model. Okay, so information about the model is restored in UML meta model. Okay, so it is written as the stereotype in galimeds. Right, constraints are extending the semantics of an element by allowing us to add the new rules, and it can be written in curly braces, and then constraint name is there. So here the ticket ID. So if you want to specify ID is there, ID should be unique. So each ticket has a unique ID. That is the constraint. Tag values allows us to add new ad hoc information about the element specification, and it can be represented as the tag name as equal to its tag value. So tag name here is version and tag value is 1.1. Okay, so these are the extension mechanisms are there. Let's see some different examples of stereotypes. So this is another one stereotype, right? Stereotype naming elements. You can specify stereotype icon is there. Okay, these are the preferred basically. Okay, so this is also common icon as well as the stereotype elements can be specified. Okay, so here the relationship is stereotyped. So call is one kind of relationship in between job manager and scheduler. So a stereotype introduces a new modeling element, and so we must always define semantics for our stereotypes. Each model element can have many different kinds of stereotypes. Okay, understood? Okay. Now we'll discuss the last topic, that is UML profile from basics of the UML. So UML profile is nothing but the collection of stereotypes, tag values, and constraints. So a profile customizes a UML for the specific purpose only. Okay. So when you are collecting the stereotypes and constraint, you are considering this is for only specific purpose. And that is known as what? UML profile. Where exactly stereotypes extend one of the UML meta model elements, for example, class, association, etc. So any element that gets the stereotype also gets the associated tag values and constraints. So all those are collected into one thing that is known as UML profile. Okay. So in this way, today we have discussed about the basics of UML language. So unified modeling language. Okay.